Welcome back to the second part of Trig 6.7 notes. We're still talking about rectangular equations to polar equations or polar equations to rectangular equations and making those sort of conversions. This problem is asking us to take a rectangular equation, so an equation that has an x and a y, and write it as a polar equation. Whenever you are writing a polar equation, now we know that a polar coordinate is an r comma theta. That's a coordinate. But when we deal with a polar equation, we want to write it with an r and a theta in it, and we want it to say r equals something. So we'll solve it for r. When it's a rectangular equation, we want it to say y equals something. So polar equations, r equals something. So let's make some substitutions. What we know, I need to change an x and a y into an r and a theta somehow. Here's the substitutions I'm going to use. I'm going to replace an x with an r cosine of theta. And I'm going to replace a y with an r sine of theta. So we're going to subtract r sine of theta. Finish writing this out, add 2 equals 0. Now my goal here is to be able to solve this equation for r now. So that's where this r something comes in. In other words, it means solve for r. So first thing I'm going to do is multiply in the 3. I'll get that. Again, if I want to get the r by itself, right now I've got two different r's in my problem, and I can't combine them together because one's a cosine and one's a sine. Let's get rid of the 2. So now I'd get 3r cosine of theta minus r sine of theta equals -2. And since both of these have an r, what I'm going to do is factor out an r. In other words, I'm going to factor out the greatest common factor, which happens to be an r. So if I take an r out of both of those, what that will allow me to do is make it appear that there's only one r in this problem. So if I take an r out, I'd be left with 3 cosine of theta minus the sine of theta equals -2. So now it appears that there's only one r in this problem, and I can solve. So right now the r is being multiplied by 3 cosine minus the sine, so I'll divide by that. And I'll do that to this side as well. Which will leave me then with, these will both cancel out, and I'll have an r equals -2 over 3 cosine theta minus sine of theta. I know I'm done because I've solved it for r equals something. Okay, so again, that was my goal to keep in mind when you're trying to write a polar equation. It's usually r equals something. Rectangular equations, we usually solve for y so we can graph them. So rectangular equations, when you solve for y, you're done. Polar equations, when you solve for r, you are done. So that would be my answer here. Okay, for our next problem, we want to go from a polar form to a rectangular form of the equation. So I'm given the polar form because it has an r in it, and I want to go to the rectangular form of the equation. So that means what I'm going to have to do is figure out a way to get, in this case I have an r, I need to change an r into either an x or a y somehow, or a combination of both. It doesn't necessarily have to be just one x or one y. So thinking about all of the different formulas we discussed on the first page of the notes of part 1 of the video, we said that r squared is equal to x squared plus y squared. We actually said that r is equal to the square root of x squared plus y squared, but if we were to square both sides, we'd end up with that form of it. We know what theta is equal to, we know what x is equal to, and we know what y is equal to. So what I'm going to do in this problem is, if I want to use this version of the form, I would need to get an r squared. So I'm going to square it, and then I can use that form. So if I square both sides, I end up with r squared equals 25. Now I make the substitution. I know what r squared is equal to. I've got my rectangular equation. I'm going to stop right here because right away when I look at this, I can see that this is a circle, and this is the form that I would need it in to graph it. So I'm going to leave it like this. I could actually graph this pretty quickly when it's in this form, versus if I went and took the time to solve it for y and tried to graph it like that. So even though it doesn't ask me to graph it, we usually want to get it into the form that's easy for us to graph, and in this case that is if you just leave it as the form of a circle like that. But I know that this is a rectangular equation because now it's got the x's and the y's in it. It doesn't have an r in my problem anymore. Okay, for this next one I want to go from polar form of an equation, theta equals 76 degrees, to rectangular form. So in this case I've got a theta, and I need to change that into an x or a y or some combination of both of those. So what I know is that if I'm trying to get theta to go away, the way that I can do that is I can use this identity that I know that the tangent of theta is equal to x over y. Well, I don't have the tangent of theta in my problem, I just have theta. So if I apply tangent to both sides, so tangent of theta is equal to the tangent of 76 degrees, then what I can do is I can go through and I can make my substitutions. I know now that the tangent of theta is equal to x over y. In my calculator I'll plug in the tangent of 76, and I end up getting that the tangent of 76 is 4. So now I have this, that x over y is equal to 4. So let's get it into a form where we can actually graph it. I know it's going to be a linear equation, so I want it to be solving it for y. So to get rid of the x, I would multiply both sides by x. So this would be y equals 4x, which would be a linear equation. Again, keeping it in the form where we can graph it is typically a good way for us to know when we should stop. I know it's rectangular because now it has an x and a y in it instead of a theta. So this time what I had to do was apply tangent to both sides to be able to use that form. If you have something like this one, where you're going from polar form to rectangular form and you have r is equal to 2 cosecant of theta, what I want to do right now is, I can't really deal with cosecant, but I can deal with the reciprocal, which is the sine. So first thing I'm going to do is change it into sines. So this would be r is equal to 2 over the sine of theta. And again, what I'm looking to do is change r's and thetas into x's and y's. So I know that there's an identity out there that says that x is equal to r times the cosine of theta, and y is equal to r times the sine of theta. Well, what I know in my problem is that here I have an r, here I have a sine of theta. So if I was to just manipulate this, so I get the sine out of the bottom, so I multiply both sides by the sine of theta, now I have r sine of theta. I have this. I know that r sine of theta is the same as y. So let's replace r sine of theta with a y, and we get it equal to 2. And so, have I successfully changed this into a rectangular form? Yeah, this is a horizontal line. It's got, in this case, it just has y's and it doesn't have any x's, but it doesn't have any polar coordinates or polar forms in it. In other words, it doesn't have an r's and thetas in it anymore. So I was able to manipulate this to get the r and the theta to go away. And now I have a equation that is a rectangular form. And it's solved for y. I could graph that pretty easily if I had to.